Sweep 2 direction is to the right. Sweep 2 distance is 5. Sweep 2 position is 7862. What is the sweep 1 position? 7862. Sweep 2 position is 7862. Sweep 1 position 7862.1. Alright, well obviously these numbers are lying to me. Because the sweep 1 position and sweep 2 position cannot possibly be the same damn number. Like, it's mantling up by 100, which is what should be happening. Something must be going on here. Like, something must have just happened that we changed for this mantling stuff to just not work anymore. Yeah, what is this? Alright, so the Z is different. And the direction is such. It's 110. Well, this is just frustrating. Like, what is different? What have we done? Like, we didn't change this code whatsoever, and all of a sudden it's not working. If the ray distance is greater than the mantle height, then alright. So let's just take another look at this. See, why is the height 100? Our height is 169.19. The mantle height is gigantic. So what is the step 1 direction? What's the step 1? So step 1 start is our movement direction at back 1. Well, thank you for hosting, Ishmugel Osukami. Not sure. I'm starting to totally fade out here. I'm just like messing with collision data. But basically what's going on is our what is our position that we're currently working with? It looks like the difference is like 100 is the height that we've calculated here. Thank you for following, Ichimuru Osukami. I'm just starting to lose it. See, how long have I been streaming? I've been streaming for over 9 hours, so I've been working on this random crap for way too long here. So yeah, I've been working on coding for far too long. And the reason we're failing this mantle is because well, what is our player's position at the moment? Like, our player's position at the moment is, this is Bitey. Our position is 7, 8, it's 1553. So, alright, we've got the right thing for like 1553. It's got to be that our z, we're not adding enough z to this thing. I think it is supposed to be Shmugal Osakami. Well, yeah, I'm just failing at, reading words. So the Z position is wrong for some reason. Like, the step 3 impact normal should tell us. Do we have the step 3 impact normal? Step 3 hit, impact normal is 1, so it should be straight up. Hello, Lich Shield. I am starting to go insane over here because I've been coding for too long, but hopefully you're feeling and doing better than I am. Let's see, so our impact normal is 1, so we're going straight up, which is correct. The sweep 1 distance is 110. The sweep 1 distance is 110 for good reason. 110 should get us on top. The problem is it's not far enough. So like the float vertical nudge. This thing is being annoying. Wait, is Visual Studio just locked up? The vertical nudge is 10, so this thing should be like way... Alright, we're just gonna put in absolutely ridiculous value here. Take a break? Yeah, well, I'm not gonna be taking a break. I'm gonna be stopping for the day, so I want to get to a good stopping point. And I don't want to stop with stuff just all sorts of messed up. Because then when I like get back into it, it's going to take too long. And if I can just get a little bit here, then we'll be okay. The game looks amazing. Well, thank you. That's compliments. I think that should be given to Adam. He's the one doing all the awesome artwork. Alright, so let's see how far I can actually mess with this vertical nudge. And like kind of how messed up it is. Because it should be pretty close. Yeah, this is my sorts of drawings. They look like this. I'm just like, so you're going along a slope at like this speed and you fly off, and when should we clamp to the ground, and what if you're running along the edge and then it's a bottomless pit and then you clamp to the bottom and then you die. Yeah. It's definitely ugly code. You're stretching the definition of the word art there, Karakan. Alright, so it looks like there's just a little tiny issue there with the mantling. And that's pretty much all it needed, was just some of that. How come you can stand on that? That makes no damn sense. I mean, there's nothing in this. This is just... That's just math being wrong. And now I can't reproduce it. Oh man, why? Alright, so I can reset the mantle height to like 20 as it should be. And let's make sure that we mantle as we should. And the movement is all sorts of screwed up right now because I'm just using it for testing. Alright, so let's see if we can fix this jump kill real quick. Yeah, so this is what we have right now, which is if the new velocity.z is greater than 0, then and kill jump, then we subtract much more than other words. But really what we want is new velocity.z needs to be we need to have actually jumped. So we'll do like, and you're in the air because you jumped. All right. All right, so jump. If current state is on ground, then error because of that equals that. All right, so we need like We need, if we move along the in there because jump is true, and we want to say like curse state equals what is this? Update locomotion on ground. What we need to do is this snap object to floor is what's actually going to do stuff. It's basically what I want to do is we want to set the physics state and we're just going to set mair because jump to false. And we'll set it to true right afterwards. So do we ever actually directly set this? Only inside of the place object smartly. So let's just call set physics state to on ground in the air. So we'll do it like this. So let's just keep fixing all of this garbage. And we'll call our setters because we can control the other objects. We can control our variables for our state. Okay, so this should make it so the only way that you can kill your jump is if you actually jumped yourself. So I should be able to run and jump off this thing, and it's not going to have that super jump. Because we didn't give Bitey a super jump. We just want a normal jump. Ah. Why you gotta be like this, Bitey? Why you gotta be such a pain in the ass? So I guess if he wasn't a pain in the ass, it wouldn't be Bitey. Right? I can totally feel my mind just losing it at the moment. It's really funny. It's like one of those feelings when you're So I just did the opposite of what I wanted to do. So what I want, if the velocity is greater than 0 and kill jump, no, this is correct. Like, when you run off that, you shouldn't be able to influence that speed because so you should always have the super jump, basically. Because you can't change that speed because you ran off the cliff. So you should just be moving at that speed. And gravity is actually just doing exactly what it should. So that's what's going on there. So something's happening there where our upward velocity is just massive. Thank you for following the minion. We're just messing around with our physics at the moment and trying to figure out why our character's doing what they're doing. And the question is if it's correct or not. And I think basically what I want is this ore here. And it doesn't really make sense at all from a gravity perspective, but basically it's like the jump vertical is automatically killed unless you started the jump yourself. Because the other thing that's happening is like we have a very large like z-axis. I mean a very large z-axis. Z is up. Velocity because we're running up the slope. Then all of a sudden like we're now in the air, so we should be moving up. But the problem is if I let go of the key, he's got a lot of air control, so immediately stops moving in the y-axis, which is right and left. So he appears to like stop and then just like fly up in the air, but that's actually correct because of the air control, and the air control is not tuned at all for this. So it's one of those sorts of things where it looks totally wrong, but it might actually be what we want. It's just it needs to be tuned to look better. Yeah, those physics looks totally right. Everything's good. Yeah, that feels a lot better to me. Yeah, okay, so that's pretty cool. What is the programming language? Well, the programming language here is C++. That's what all the actual coding stuff for Unreal 4 is written in. And Unreal 4 has another language, quote unquote, which is blueprints. And blueprints look kind of like this. I'll pop open the thing that actually controls the player. So blueprints are Unreal 4's visual scripting language. So for instance, this is on the update tick event. I don't know if you can see this super well, but there's like on the update, we set our current delta t to a variable, and if the console is not open, then we let you move. So you have like, we're gonna grab our left stick, up, down, left, and right values, and we're gonna grab those and like basically set our wanted velocity for our character. Yeah, the menu, that's what I was talking about. I was like, there's things that look wrong but are right, and when you've been coding for 9.5 hours, your brain doesn't always work properly. But the visual scripting language stuff here in Blueprints is more for designers and people like that to work with. And the idea is you do all like your heavy lifting, like all your complicated random vector math and logic in C++ land, and then your artists and designers can work in this nice, easy to use scripting language sort of thing where they're like, okay, so if the B key is set to true, like is triggered, then create effect by class test explosion and with the position, and that's all they would have to do, and that code right there makes this little explosion over here. So I could change this to be something else, like instead of making a test explosion, I could make energy channel 2, which I have absolutely no idea what that even does. But let's go see what it does. Yeah, it's a different effect entirely. And it doesn't actually disappear. It's a totally broken effect. So I should probably not spawn that one. But yeah, so that's how people can script out stuff. Alright, so that's fixed. Let's double check a few things. Let's just make sure that our character is still running as intended. We can run over these slopes without getting all sorts of screwed up. We can run over these slopes. And let's go to the curly queue, make sure we can do that. So we can run up that, all that fun stuff. We can jump out in here, do all that. And we can run up these slopes all the way to here. And then we can run down them. Yeah, I'm teaching myself blueprints too. I know C++, but the blueprint stuff is still kind of, what am I doing? Because I'm not exactly sure how they're kind of intended to work, right? That's kind of one of those things sometimes is you know how you would use something, but you're not sure how they have set it up to actually be used. So I'm going to test out Adam's test level, which is what he has been messing with. And Bitey used to just really not be able to run along this. Like, he used to just like freak out and get, jump in the air and not be worth anything. He's just able to just run along this. Like this rock has this slope here, and we can just run straight down. But yeah, he's not doing a whole bunch of crazy shenaniganry like he was before. And we can always kind of tune some of these variables here for the running off of objects to make it so he doesn't stick nearly as well to the floor. Like, I think we can actually do that right now. Let me take a look at what we've got for the player. Standard player is looking at Bitey perspective player, which is looking at Bitey player proxy, which has got Bitey movement. So Bitey movement has got a floor stick distance base of 100. Maybe we should just lower that to 20 and save that and see what happens over on that rock. And I think this has to do with that Z. We actually added in way too much for the Y component movement, allowing us to snap to the floor. And we'll need to clamp that to a certain value so he would just like fly off of that. So why don't we do that You don't know. Alright, so you know C#, but you have no idea how to use Unity, so I feel like it's kind of easier to use UE4. Well, one of the big things that we've run into consistently with Unreal Engine 4 is that a lot of systems don't work out of the box like you'd expect. So you gotta watch out for that sort of stuff. So we're gonna make a function here, which is gonna be calc floor stick, and instead of this sort of thing, we're gonna pass in the movement distance and the movement direction vector. So it'll be a const f vector reference, and we're going to have this float stick to ground is going to be equal to this movement distance times the movement director z, and then we're going to add in the movement. It's going to be movement vector. So we want the movement distance times that, and then we also want like a certain percentage of the y to go in here as well. And we want to clamp it to something like something reasonable. Like, do we have like our end movement? You haven't gotten any controller input yet. Yeah, controller input was a real pain in the ass for me for Unreal 4. I'll let you know kind of what I did. What I did was I overrode the input class for the window. Let's see, where is that? Yeah, so I made my own viewport client and set the editor to use that. And if you have your own viewport client, you can capture the input keys, input axes, input characters, and input touches, and all the mouse stuff. And then I kind of wrapped it up in my own stuff because I was unhappy with how Unreal 4, you had to have like a player pawn, and then a player pawn had to, grab like a controller and all that stuff. And I thought that was a little frustrating to work with. And let's see, we want like a maximum stick here for this. Oh, we'll say if it's like over 100, then extra stick equals 100. And we'll Alright, so what? Calc floor stick. Calc floor stick, we're going to do movement distance and then movement direction vector. So let's see, the second one was this. So we want to pass in, want the movement distance. Yeah, the issue was, the main thing that I wanted was I wanted the ability for my input system to just tell me, like, is the arrow key on the keyboard pressed? You know, like, is the A key pressed? Just straight up, like, is that exist? You know, like, I didn't want to have to go through the pawn to be able to do something with input, which is not how Unreal's set up. Unreal's set up, you know, for you to have your controls very specific to the player and stuff like that, which makes a lot of sense, but it can be pretty limiting if you don't want to have, like, the training wheels on. So I have another input system that I kind of grafted on top of it, which maps actions to things. Like, I've got an input mapper, which I've got all these, like, standard actions, like, you know, A key, B key, X action, and all these are actually mapped to one or more buttons on the keyboard or on the controller itself. So the A action is always the A action, regardless of if it's the actual A key on the keyboard or on the controller that actually does that. And then I have, like, this whole mapping system that deals with that and snags controllers, and, you know, like, I've got, like, set controller, unset controller for, like, you know, these things where I can actually, like, get all the controllers and assume the controllers and all that, because there's stuff like, if you rip a controller out or something, you know, where, and you plug, like, another controller in, like, you know, what happens, and sometimes you want a little bit more control over what happens than just letting the engine magically try to figure it out for you, which it usually doesn't do a very good job of. And I also didn't like the blueprint functions to grab the input key states. So with this, I can just be like, is this controller connected, or is any controller connected? Okay, now is the A button pressed for player 1? And I don't have to be inside of the player controller to do that. I can do that from anywhere. So that took a little bit to set up, but it's definitely possible. Alright, so what we want is the movement direction vector. We want the movement distance, and we want the movement direction vector passed into this. Alright, and we'll go back to fixing up this calc floor stick. So we're just calculating it in one place, so we can then easily change our floor stick. Yeah, one of the other things that was annoying was getting, like, the graphics, stuff like that. Like, one of the things that, up until Unreal 4.16, which just came out, which we are on now, they didn't actually have the upper left-hand corner of a display. So if you wanted to, like, switch your game from, like, monitor 1 to monitor 2 or monitor 3, like, you just couldn't do it. So it was pretty funny. I was like super upset. I was like, I can't switch the monitors for the windows and all that crap because I don't know where the windows are. I had to like go edit the core code so I could do that. And yeah, the minion. If you're going to be working with Unreal 4, if you're not already doing it, I would highly recommend grabbing it from GitHub and compiling the editor from source and all that, as opposed to running like the Epic Games launcher. That's if you're planning on doing any, real C++ engineering on it. If you're not, then don't worry about it. But if you are, then I would. I've been working in Unreal for the last, 5.5 months. So that's my Unreal 4 experience. It's not like I'm some crazy Unreal 4 guru or anything. I've just hit my head against a lot of walls. You'll be doing blueprints mostly. Well, I would say good luck. I don't think you can make an entire game with just blueprints, but I think you're going to hit a ceiling where there's going to be things that you wish you had C++ there for. That's really funny. He's like, But I mean, that kind of makes sense, right? Like, if your character is running along these, is going to be dunk, 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 dunk. So that's with a 0.1 movement distance extra stick with a limit of 100. Let's change the limit to 250. Why don't we just do like a float max stick? And we'll throw this like stick inside of the actual movement data here in a second, so you can actually save per character what you want that stickiness to be. The other thing that's cool about grabbing the actual Unreal source from GitHub is that if you need an example for something, you can always go Control F the whole code base and figure out some example of how to do something. Because they've done a good job of dogfooding their own work. So if you're ever like, how in the hell did they do this in their basic editor, you can get at least an idea. And also, especially with having the code base there, you can figure out what blueprint functions are available. And kind of read them directly if you can't seem to find something. So I'm wondering why we're now falling off of this thing. Because 500 units should be... I don't know, maybe I can just... I want to make sure it has the same behavior as before, because maybe I fat-fingered something, so I might just remove the maximum real quick and see if he's still donking off the surfaces. Yeah, let's just remove the max stick. What day is it? It's Sunday. Alright. Let's see, the movement direction, the distance was 66, didn't stick because the distance was 67, which is greater than 30. An extra stick was 8. Extra stick was 9. Alright. So it looks like it's just too small overall. So maybe we can do like movement distance times like 2. I'll plug it in real quick. And we're probably going to want to parameterize these things so that in data we can mess around with the movement sticks. Thank you for following, Bug Owl. Hopefully you're having a good day. I'm almost done with my day of work, that is. So let's see. Extra stick is pretty small.